of the review for Unit 1, Part 1. This is starting the inverse section. So remember, when you see that little -1 power on your function notation, that's the inverse. Okay, so they want us to calculate the inverse of x of f of x equals -2 times the square root of x plus 5 minus 2. Okay, so calculate the inverse. Step 1, switch the x and y, right? Or really, step 1, replace f of x with y. Does everybody understand f of x is the same thing as y, right? Okay, so if you want to, you can just write over it with a y, or you can rewrite it with a y. I really don't care. Okay, but then we are switching them. Okay, so we're going to put x equals -2 times the square root of y plus 5, and then minus 2. Okay, and then we are solving. We want to solve for y. We want to get y by itself. So now it's basic algebra. Okay, so we're going to move the constant to the other side. We're going to add 2. We've got x plus 2 equals -2 times the square root of y plus 5. Okay, now I need to get rid of the coefficient, that times -2. So I'm going to divide by -2. What you do to one side, you do to the other. Okay, so I'm going to come over here. So this x is an understood 1 coefficient. So 1 divided by -2, that's -1/2 x. And then 2 divided by -2 is -1, so -1. And then we're left with the square root of y plus 5. Now, how do I get rid of the square root? Square. What I do, that's going to get rid of the square and the square root. What you do to one side, you do to the other. Okay, so I'm going to have -1/2 x minus 1 squared equal to y plus 5. And now what's the last step? Subtract that 5. Can I combine this -1 and this -5? No, this is in parentheses being squared. This is not. This needs to go on the outside. So this comes out to -1/2 x minus 1 squared. And then the -5 is on the outside. Now you can keep this as y and put the little -1 to indicate that it's inverse. I'm going to go back to function notation and indicate inverse. So that's it. That is the inverse function. Feel okay about that? So replace f of x with y, switch x and y, and do your algebra to solve, and then notate that that's the inverse. Okay, we're going to do the same thing with number 22. So I'm going to call this, instead of g of x, I'm going to say this is y. So I'm going to switch the x and y. So I'm going to say, okay, x equals, then it'll be y plus 4 cubed minus 6. All right, so to solve this, I'm going to move the constant first by adding the 6. Got x plus 6 equals y plus 4 cubed. How do I get rid of the cube? Cube root. The opposite of square root was square. The opposite of cube is cube root. So it's like a square root. It's a radical, but it's got the 3 index. So the cube root, that's going to get rid of the cube. But what you do to one side, you do to the other. I'm going to take the cube root of that side as well. Okay, so now we are at the cube root of x plus 6 equals y plus 4. Now what? Subtract the 4. Can I combine the 6 and the minus 4? No, this 6 is inside the radical. This minus 4 is not. So make sure that you do not combine those. So x plus 6 is inside, minus 4 is outside, and that is equal, this was g of x, so this is the inverse of g of x. Guess I could have boxed in that other one up there too. Okay. Remember, it matters. You can't combine those because one's inside, one's outside. This is your H. This is left 6. This is your K. This is down 4. Okay, so just remember to keep those separate. Don't accidentally combine those when one's inside and one's outside the function. All right, so we're still talking about inverses, but they want us to use the table of f of x, so this is the original function, to evaluate these inverses. Okay, so I could just use this table and understand that I'm going, what is the input or the x of the inverse would be the output of the original, right? So I can just know that and say, okay, I'm going to look for these values in the y column and see what the x is. So I'm looking for -1 in the y column. My answer is -4. Okay, I'm looking for 0 in the y column. My answer is -2. Looking for 2 in the y column. My answer is still 2. Okay, if reading the graph, or excuse me, the table backward like that is not good for you, if that does not make sense, actually create a table for the inverse. Okay, if this was x and y, on the inverse, they switch, right? So all of everything that was in the f of x column is now in the x column. And what was in the x column is now in the y column. Okay, and then you can look at it going forward. You could say, okay, at inverse f of -1. That means on the inverse function, my input's -1. My answer's still -4, right? So it doesn't really matter which way you're looking at it, from the original going backward or from the inverse going forward. That's just a you preference question. Okay. If it helps you to make a table of the inverse, go ahead. Doesn't hurt. All right. Now this is the same concept, except this time we're now it is harder to make the graph of the inverse and use that. So I don't know that I would recommend that because it's kind of extra work where a lot of you might make a mistake. Okay, so this is the graph of f of x, but I'm trying to evaluate inverse of f. So just remember, look at the y. If this is the x for the inverse, it's going to be the y on the original. Okay, so when it says I want to find inverse of f of -2, that means it's the y value that's -2 on the original. So I go to -2 right here, see where I am on the graph. What x value is that at? At 1. Okay, I want the inverse's input is 1, so that means on the original it's the output, the y is 1. So where the y is 1 on my graph, oh, I actually have 2 answers here because it crosses there twice. So here and here. Y'all see that? So that's at, I don't know why I put a mark way down there. Being silly. So that's at -2. And it's at, I don't know if that's quite at half. I'm going to estimate to the nearest half, so I'm going to say about -half. That one technically had 2 answers. Okay. And then we're looking on the input on the inverse to be 3. That's the output on the original to be 3, which would be here. So there's my graph. What's that x value? -1. Good. All right. So inverses algebraically, inverses by table, inverses by graph. Okay. And last but not least, verifying if functions are inverses or not. Okay. So the composition of two functions should come out to x if they are inverses. Okay, so if I do f of g of x or g of f of x, it should all undo each other. Everything should undo itself and just leave me with the variable x. If it doesn't leave me with that, then those are not inverses. Okay, so doing the composition here, you can choose which way you do it. So f of g is probably the more common one for people to choose. So that means I'm going to actually get a second color here. I'm going to put the g of x function, this whole thing right here, inside the f function, wherever the x is. So I'm going to replace that x, that whole thing. Okay. Oof. And then that's squared. We're going to have to FOIL. Okay. I'm glad I caught that. I'm going to go the other way. I'm going to do g of f of x. It's going to be a little less complicated to simplify. Because remember, you can do it either way. It doesn't matter. So I'm going to put the f of x function, this whole thing, inside the g of x function for x right there. So I'm going to make that, I'm going to go that way. That one's going to be a little easier to simplify, I think. Okay. So I've got the square root of, and then I'm going to plug in there, and then I've got +4. And then on the outside, I've got -1. So I'm plugging in x minus 1 squared -4. Nothing to simplify in that set of parentheses, so technically that can just be dropped. So I've got x minus 1 squared -4 +4 all under the radical, and then the -1 on the outside. What happens to that -1 + 1? Or excuse me, -4 + 4. Yeah, that's just a 0. It's gone. Okay, get rid of that. All right, now you've got this binomial squared under a square root. So what happens to the square and square root? Yeah, those cancel each other out. Okay, so the square and square root cancel each other. So now I'm simply left with x minus 1, which I don't need the parentheses. And then I've got this -1 out here. So I've got x minus 2. Did I get just x? No, I didn't. So these are not inverses. Okay, this did not equal x. It equaled x minus 2. So these are not inverses. Okay, it was close. It almost all canceled out, except that was instead of a +1 and a -1, it was 2 -1s. Oh, did I write it wrong? Oh, man. Okay. Good catch. I wrote it wrong. It is x plus 1, and I wrote it in here as -1. So that is supposed to be a plus. So that is supposed to be a plus here and here, which would indeed cancel out and leave us with just x. So that one does work. It does give us equal to x. So yes, these are inverses. Your other option, just like I said when I was going over the quiz, if you don't like composition, if composition is hard for you, you could just pick one of these and find the inverse algebraically. Switch the x and y, find the inverse, and see if it matches the other equation. That's another way to find out yes or no they're inverses. So yeah, you've got two options on the process here. You can do the composition. I'm doing the composition because that's what the instructions wanted. But really, if it's just a question asking a yes or a no, you could use whatever method you wanted on the test. Okay, so for 30 over here, let's see. I'm going to do the same thing. Instead of plugging into this and having to square it, I'm going to plug f into g. So I'm going to do g as the outer function again, and f of x as the inner. So I'm taking this whole f of x equation and plugging it in for x right here. That's the substitution we're going to make. Okay, so this is going to be 2 times the square root of that plus 7. So that is 1/2 x minus 7 squared. Okay. You can go through. There's nothing to simplify in those parentheses. You can probably tell right away that minus 7 that you would want to cancel with that plus 7. They're both under the radical and one's being squared and one's not. They're not going to end up canceling out, are they? So you can kind of tell quickly, these are not going to work. It's not going to work. Those are not going to be inverses. Okay, so sometimes you can tell quickly this is not all going to cancel out. It's not going to simplify to x. Okay, so since that is a relatively quick one to see, I'll show you your other method so that you have that in your arsenal as well. Okay, so the other option, you can pick either one and just switch x and y. This one looks a little less complicated, so I'm going to actually switch this one. So I'm going to pretend that's y. I'm going to switch x and y and solve. So I would divide over the 2. So that's 1/2 x. And then I would square both sides to get rid of the square root. Okay, so that becomes 1/4 x squared equals y plus 7. And then I would subtract the 7 over. So I would have 1/4 x squared minus 7 for the inverse. Does that match this other equation? No, it does not. So these are not inverses. So you can check it with composition, or you can just find one of the inverses algebraically and see if they match. You have the options there. Okay, I've already did these composition questions in another video, so I'm going to stop this video here.